This video we're going to look at how we multiply and divide algebraic fractions. Now we're going to start with the first example we're going to start with is this one here, which is a mixed number times a normal fraction. So it's good to understand the principles of cancelling down fractions, normal fractions, numerical fractions before we go on to algebraic fractions. To do one of this, the first thing you do would be to convert your mixed number to be a top-heavy fraction. So we convert our mixed number to be a top-heavy fraction first of all by doing 6 times a 5 gives you 30, and then plus this 5, so 30 plus 5 is 35 over 6, and we're now multiplying that by 3 over 7. So all I've done is converted my 5 and 5/6 to be 35 over 6. Now what we do is a wee bit of cancelling down. So we use a different colour here just to show 3 divides into itself one time, 3 divides into 6 twice. So I could do that because the 3 was on the top and the 6 was on the bottom. So you can see they weren't directly above each other, above and below each other. They were across a wee bit, but that's absolutely fine. Same idea here. 7 goes into itself once, and 7 goes into 35 5 times. So what I'm going to do is just, it can get very messy. So what I'm going to do is just write this out again. So it now becomes, what was that? 5 over 2 times 1 over 1, and then all you're doing is multiplying along the top. 5 times 1 is 5, and 2 times 1 is 2, and if you can, as you can in this case, if it's a numerical one like this and it's a top-heavy fraction, you could write that as 2 and 1/2. Okay, same idea in example B. There's no cancelling we can do here. We've got an x on the bottom, and we've an x on the bottom over here. They're both on the bottom, so there's nothing we can cancel out. So unfortunately, this one, all we can do is multiply along the top. 2 times 5 is 10. X times x is x squared, and that's as good as we can go. Okay, example C is a wee bit trickier. There's a lot going on here. You could do this a couple of ways. I think in one like this, I would probably just multiply out first of all, multiply along the top, multiply along the bottom, and then I would cancel. I won't always do this, but we'll see why. Okay, so along the top, you've got 3 times 4 is just 12. X times x squared is x cubed, and y times y is y squared. And along the bottom, I had 4 times 5, which is 20. And then you have x times y, which is xy. Now, if we have a look at this, what number now divides into 12 and also into 20? So the number 4 goes into 12, and number 4 goes into 20. So 4 goes into 12 3 times, 4 goes into 20 5 times. So when we go into our answer, it's going to have a 3 and a 5 on the bottom, 3 on the top and a 5 on the bottom line. Now the next thing we're going to look at is our x and our x cubed. So x and x cubed, both of those are divisible by x. So if x divides by x, it just goes down to 1. If x cubed divides by x, it goes down to x squared. And here we've got y squared on the top and y on the bottom line. Y divides into both of those. Y goes into y once, y goes into y squared, y times. So I'm going to have, that's my final answer, 3x squared y all over 5. Okay, example D is where it gets a little bit trickier. What you must do in these examples from here on in is factorize wherever possible. So I've got x over x plus 1 on the left part of it. There was nothing I could factorize, but over here I had 2x plus 2, so that I could pull out an x plus 2. So I could pull out 2 outside a bracket, leave me x plus 1 inside a bracket. Now we're into our cancelling down. So x goes into itself once, x goes into x once, and then you've got x plus 1 all goes into itself once, and x plus 1 goes into itself once. So what you're left with is just 1 over 1 times 2 over 1, which just becomes 2 over 1, which becomes 2. So this very ugly looking expression at the start really is just worth 2, and that's it. Okay, this one I'm not too sure if there's going to be anything we can cancel down here. We'll have a look and see. I just like to change my expression to be x plus 3 all over 1. Just makes life a wee bit easier. And then all I'm going to do is multiply along the top line. So I'll have x plus 3 upon x minus 3. And you can see my bottom line is already factorized. So there's nothing I can do really with this one. That's really as good as we can go. You may want to multiply that one out. If you multiply that one out, what you would get on the top line, it's the difference of two squares. It's x squared minus 9. And your bottom line, if you multiply it out, you're going to have 2x plus 12. But to be honest, I think this middle one is as good as any. It's fine. Okay, example F looks very difficult, but it's actually not. It's probably much easier than some of the previous ones. First of all, I've got my x here, can cancel with this x. I've an x plus 2. It's multiplying everything in the bottom line, and it can cancel with this x plus 2 up here. And then I've also got a 2. 2 goes into itself once, and 2 goes into 8 4 times. So what we're left with so far, our expression becomes x minus 2 over 4 times 1 over x plus 1. And then just multiply along the top. You're just going to have x minus 2 on top, and on the bottom you're going to have 4 upon x plus 1. And again, there's no real benefit to multiply that out, so that's as good as we can go. Okay, the next example G, remember what we've got to do is factorize everything first. So in the top line, we've got x squared minus 9. This is the difference of two squares. Remember, x squared is something squared, 9 is something squared. So it factorizes to be x minus 3 upon x plus 3. And that's all divided by 2x. And then we're multiplying by 3x squared over, and just put it in bracket, makes it a lot easier, x plus 3. Once you've set it out that way, it makes it very easy to see. Your x plus 3 cancels with your x plus 3. And you've got an x which will cancel, and this will cancel down, this x squared will cancel down to just be x. So then just multiply along the top line. You've x minus 3 times 3 times x. That just becomes 3x upon x minus 3. And on your bottom line, all you were left with was just 2. And that's it. Okay. Okay, example H, fair bit of working out to do for this one. You've got to factorize these, and it's a bit awkward here. We've got 4 summing products to do. So at the side here, I'm going to do the working out, please. If x squared minus 4x minus 5 is my first quadratic element to factorize, the sum is minus 4, its product is minus 5. So my two numbers are going to be minus 5 and 1. So it factorizes to be x minus 5 upon x plus 1. My next one, I'll do the one on the bottom left. It was x squared minus x minus 6. So my sum is minus 1 and my product is minus 6. So the two numbers which add to give minus 1 and multiply to give minus 6 are minus 3 and 2. So that means it factorizes to be x minus 3, x plus 2. Okay, I'll run out of space here, I know, so I'll go off the page here. So you may need to take a wee bit of extra work off your workbook. Next one was x squared minus 5x plus 6. So my sum is minus 5, my product is 6. So my two numbers which add to give minus 5 and multiply to give minus 6 are minus 2 and minus 3. So with this expression factorized to be x minus 2, x minus 3. My last one was x squared minus 6x plus 5. So my sum is minus 6. My product is plus 5. So two numbers which add to give minus 6 and multiply to give minus 5 are minus 1 and minus 5. So the expression factorizes to be x minus 1, x minus 5. Okay, that's a fair bit of work just to factorize. Once you've done that, that really is a hard part of the question done. You then rewrite your expression, putting those all in. So it was x minus 5 upon x plus 1. bottom one was x minus 3 upon x plus 2. And the top right one was x minus 2 upon x minus 3. And the bottom right one was x minus 1 upon x minus 5. Okay, now you've done that, you really have done a hard part to get to here. And at an exam, you would definitely get marks for doing all of that working out, don't worry. But you've done the hard part, you might as well go on and get the rest of it. So what you can factorize anything, it's something to remember if it's on the top line and it's also on the bottom line. So here, first of all, I've got this x minus 5, nice neat line through your x minus 5, and also your x minus 5 at the bottom. Then you've got an x minus 3 I've spotted on the bottom here. So it can go, and this with this x minus 3 on the top. And then have a look and think, is there anything else we can do? We have an x plus 1, and this is an x minus 1. So they look similar, but they're not the same, so you can't cancel them. Likewise, you have an x minus 2, and you have an x plus 2. They look the same, but you can't cancel them. So what you're left with on the top line is x plus 1 times x minus 2. And on your bottom line, you're left with x plus 2 times x minus 1. Okay, you could go on and multiply that out, but I think for the sake of it, we will just leave it at this stage, at this point. Okay, we're now going to look at dividing algebraic fractions, and just like we did in the previous example, we're going to start by looking at a numerical example, just to remind us how we actually divide by fractions. So when you're dividing by fractions, what you do is you flip the dividing fraction. So the dividing fraction is this one. It gets flipped upside down, and your divide sign changes to a times. And then it is just the same type of question as you've done previously. So what you could do here, the nicest, best, easiest thing you could do here is to cancel out the 3. 3 divides into itself once, 3 divides into itself once. And also you could cancel out the 4. 4 divides into itself once, and 4 divides into 8 twice. So your sum, or your fraction, becomes 1 over 1 times 2 over 1, which just becomes 2 over 1, and 2 divided by 1, don't leave it as 2 over 1, 2 divided by 1 is 2. Okay, same idea for these next questions. You've just got to change it, flip your dividing fraction so that it becomes a times question, and then you can cancel. So you can only cancel once you've got it to become a times question. So x over 2, we were dividing by x over 4, so that now becomes times 4 over x. And one, I guess you could cancel at that stage, but I'm going to actually just multiply it and say it's going to be 4x over 2x. And if you have 4x divided by 2x, it just fits in twice. So the answer for that one is 2 as well. Okay, example C, I'm going to just change that to x squared over 3 times, so flip your dividing fraction, that becomes 9 over x cubed. And again, I'm just going to multiply along the top this time before I do any cancelling. You could have cancelled earlier, as I've said, but we're just going to leave it as this. Okay, you have 9 on top divided by 3. 9 divided by 3 is 3. And then you have x squared on the top and x cubed on the bottom. X squared divides into x squared once. X squared divides into x cubed x times. And that's it. Okay, tricky wee question here. We're going to have x minus 2 over 5. You're dividing by 2 minus x over 3. So times, that's going to be 3 over 2 minus x. Now, a lot of people will just leave it as this. This is quite a tricky question. But if you look carefully at this one, what you could do is pull a minus 1 outside a bracket, and minus 1 would multiply by x, sorry, minus 1 times x gives you minus x, minus 1 times minus 2 gives you, minus 1 times minus 2 gives you the 2. So here, let's just go through that again. You have minus 1 times x gives you the minus x, minus 1 times minus 2 gives you the 2. So we've just changed the way this one looks. This is a tricky example. But now once you've done that, you can see the x plus 2, I'll just put it in a bracket here, it can cancel with the x plus 2 on the bottom, leaving you just 3 on the top, and then minus 5 on the bottom. I'm just going to write that as minus 3 fifths. So a very tricky example there. but one that could come up. Okay, example E. Don't like the one set out this way, so I'm just going to write the second thing being divided as x plus 3 all over 1, and then that makes life an awful lot easier. All I'm going to do, I'm not going to do any factorizing in my first step. All I'm going to do is sort this out so it becomes a times sign, and then we're good to go. Now what we want to do is factorize where possible. So we have 3x plus 9. You can pull a 3 outside a bracket, leaving you x plus 3. And that's all over 10, then times 1 over, and put it in a bracket, x plus 3. Once it's in a bracket, you should be able to see the x plus 3 goes, the x plus 3 goes, leaving you just 3 over 10. Okay, example F. Again, not do any factorizing first of all. I'm just going to change my divide sign to be a times, and that's x cubed over x minus 5. And then we've got a bit of factorizing to do. So your top line is x squared minus 25. You should by now be spotting that that's the difference of two squares. That's x minus 5 upon x plus 5, all divided by x squared, x to the power of 8, and times x cubed over x minus 5. Again, put that x minus 5 in a bracket. Makes it easier to see that your x minus 5s can cancel, and then you've got x cubed. X cubed goes into itself once, x cubed goes into x to the power of 8, x to the power of 5 times. So what you actually are left with is x plus 5 on the top line, and x plus 5 on the top line, and x to the power of 5 on the bottom line. Okay, in part G, again, let's just write this one out with our multiplication, and then we're good to cancel if we can cancel anything. What a horrible example, we can't cancel anything at all here. So we're just going to be left with x plus 1 in a bracket upon x minus 1, and then times x plus 2 upon x plus 2. So nothing can cancel. That was just a trick example to show sometimes nothing cancels at all. That's as good as we can go. You could multiply out. If you multiply it out, just take my word for it, you're going to get x squared minus 1 over x squared plus 4x plus 4. But to be honest, this middle one I have, the one with a tick, is probably the nicest way to do it. Okay, hopefully in this one a bit more cancels. So again, we're just going to write it out, flipping the dividing fraction. So all we've done is flipped our dividing fraction, change the divide sign to multiply, and then we should be able to see what we can cancel out. So we have an x minus 3, nice neat line through it, it goes. We have got an x minus 5, and an x minus 5 it goes. So a couple of things have gone. What you're left with on the top line is x plus 1 upon x minus 2. Then on your bottom line is x minus 2 upon x minus 1. And that's as good as we can go. Okay, a bit of working out to do in this one. First of all, I'm going to sort out this sum and product. I'm going to have to do sum and product here. My sum is 5, my product is 6. So two numbers that add to give 5 and multiply to give 6 are going to be 2 and 3. And then we can factorize. So the whole thing factorizes to be, we have x on the top line. The bottom line, our two numbers, remember, were 2 plus 2 and plus 3. And then we were dividing by 5x over, and I'm just doing this in a different order here. I'm factorizing here first, which I probably should have done, x minus 2 upon x plus 2. So now we will flip our dividing fraction and it will become multiply. So it's still x over x plus 2, x plus 3, and now we're on our top line is going to be x minus 2, x plus 2, and its bottom line is going to be 5x. And then what can cancel? I have an x can go with this x up here, so I'll just go to 1. I have an x plus 2 can go with this x plus 2. So what you have is 1 on the top line is 1 times x minus 2. So that's just x minus 2 in your top line. And your bottom line, you're going to have 5 upon x plus 3. And that's a nice way to leave it. I wouldn't change that at all. I would leave it as it is. Okay, first thing I'm going to do is flip my dividing fraction. So it becomes 10 minus 5x all over 8. Right, factorize where possible again. So we have 4 on the top line. The bottom line, that's going to be x minus 2. Over here, we can pull out a 5, leaving you 2 minus x. And that's all over 8. And again, this is a very tricky example. We saw one, I guess, earlier on. Let's see how we get on here. So what you could actually do, notice this bracket, it's x minus 2. This bracket is 2 minus x. So they're very similar, but not quite the same. So I've pulled out a 5 up top here. If I pulled out a minus 5, instead of just a 5, I'd be left with x minus 2. Let's just check and see. So if we multiply this bracket, so I've got right in my 8 here as well. If I have minus 5 times x, that will give me minus 5x. That works. Minus 5 times minus 2 gives me plus 10. So up this is definitely just another way of writing this. So it does work. Once we've done that, we can see we can do a wee bit of cancelling out. So my x minus 2 cancels with my x minus 2, and I have a 4 here and an 8, which we can cancel down a wee bit as well. So 4, sort the easy one out first. 4 goes into itself once, 4 goes into 8 twice, and then x minus 2 can go with the x minus 2, leaving you just one top line, 1 times minus 5, which is minus 5, and your bottom line is just going to be 2x, and that's it.